Hi everyone. I'm going to talk about digital astrophotography. Now, astrophotography is the photography of anything in space, basically, everything from aurora and meteors at the very top of the atmosphere through to galaxies and the like millions of light years away. So I actually got into astronomy in the late 70s after my sister gave me a book on the subject. I got my first telescope in 1982. And my first camera, just 2 years later, in 1984, with the express aim of doing some astrophotography. But it was only really when digital technology sort of became readily available and the prices came down and whatnot that I really got into it and stopped dabbling and started taking it more seriously. What I'm going to do is talk about some of the techniques that I use and show some examples. And I'll try and concentrate on the techniques that are sort of accessible to everyone rather than the ones where you need a lot more equipment. Okay. So digital astrophotography has made astrophotography more accessible in that everyone with a digital camera, and of course so many people have them these days, can give it a go. There's some very simple techniques. I'll come on to the list of techniques shortly. Digital technology has also made astrophotography more productive. You've got the instant review, so you've got the images straight away on the screen, at least the raw picture, and that encourages you to experiment, and you can actually learn a lot faster than in the film days. I remember when I used to use film, that I would buy a special fast film for astrophotography. It would take me 6 months, say, with few clear nights, to actually finish the film, and by then I'd forgotten what I've done, so it's much more fun these days. You can also share the results. You can do a lot more with the processing that doesn't involve setting up a darkroom as you would in the film days. Not that I ever got into that. And you can share them online and get comments and get into discussions on forums and whatnot, which is just brilliant fun. Okay. These are the techniques that I've used over the years. They vary from the first two at the top, star trails and STARSCAPES, which are really basic. These are the ones which everyone with a tripod and a camera, virtually any lens, can give it a go. The other techniques, you need a bit more equipment and a bit more experience, and I'll show some examples of each of these. Actually, I'll say first of all, star trails. That's very basically where you set the camera up with virtually any lens on a tripod for a long exposure or a series of long exposures, which you can then process in free software called star trails to actually build up the trail of the star as the Earth turns. And you can include landscape in that as well. And you can get some really pictorial pictures that are really popular when you put them on Flickr and other sharing sites. STARSCAPES are more or less as easy as star trails, but it's best to have a faster lens. You can get, when I say faster, I mean ones with a wider aperture that collect the light more quickly. You can get some very good ones from Samyang and the like, which are very, very good value. Then we come on to the more advanced techniques, such as piggybacking on a telescope or a star tracker. So here you're actually using a telescope or a star tracker to actually track the motion of the stars to counteract the Earth turning. And that allows you to use much longer exposures and to build up more of an image, increase your image to noise ratio in your results. Also, you can take pictures of the sun and the moon through a telescope. I've got a special telescope for photographing the sun. They call it hydrogen alpha, which is one very specific wavelength. And also the moon you can photograph very easily through a telescope. You don't need very long exposures, so it's relatively straightforward, although of course you do need a telescope for that sort of thing. Next we have planets through a webcam. And this is a webcam, it just a standard Philips 2-cam webcam, but I had to prise off the lens and fit this eyepiece adapter, so it fits in instead of the eyepiece. There's also an infrared filter on there as well. And I'll show you some examples of that as well. You can take pictures of the planets and the moon actually through a telescope at very high magnifications. You take a video clip and process that with Registax. I'll list the software on the screen at the very end, in case anyone wants to download them, give them a try. Lastly, the most advanced technique is to photograph deep sky objects, which are things like nebulae and galaxies, and also comets, which are in the solar system, but need similar techniques to capture through a telescope. And this is where you actually need to guide, so you need either to manually guide, as I do, or to use some kind of auto-guiding technique which locks onto a star and keeps the telescope tracked exactly in line with the object. So what I'm going to do now is show some specific examples of what I've taken. There's just 15 pictures. I'll just say a little bit about each one. And just to in this same order, to show you the different examples of the different techniques. Okay, so first of all, star trails. This one was very simply taken with a lens that cost £25 second hand, fixed to the camera a couple of years ago in the Azores. Just a 5.5 minute exposure, and as you can see, the stars trailed slightly. You can do much longer exposures if you wish. And this sort of cloudy thing here is the Milky Way. It's the Milky Way in sort of Sagittarius and that sort of area. Then you've got the volcano there in the foreground. With star trails, it is best to actually include some scenery rather than just have the trails themselves. It's much more interesting. And if you wish, you could actually take much longer exposures or a series of long exposures, which you can stack in the Star Trail software, which I mentioned at the end. I mean, I don't really have the patience to do that sort of thing. I've done, I think, an hour as the longest duration. But if you're camping somewhere or you're set up in your own garden or whatever, you could set this going all night and have really long star trails that go, all the way across the image. It looks really stunning. The colours of the stars show up really well like that as well. Okay, this is another star trails one. This was taken in the footpath that goes the beginning of the Luxillian Valley near where I live. The foreground looks as though it's daytime, but it's actually lit by the half moon. So that's again, I've tried to include the foreground. This is only 3 times 5 minutes, so it's not a very long exposure. You could go a lot longer, but I've included Polaris there, which is the pole star. So you've got this nice circular motion around the pole star, and I think that works quite well with the scenery as well. Well worth doing. Very easy. That's the software I use. It's free to download from startrails.de. Then now we come on to Starscapes and Northern Lights. A little bit more advanced because some of this really needs a faster lens, which they can be a bit more expensive. First of all, a very simple one taken with a kit lens, or just a wide-angle lens, which I have with the camera. This is just very simple. I won't point it out. That's Jupiter and that's Venus, and that's a nice sort of conjunction in the evening with the lights of the port of Par there in the background with Par Beach. Very simple, single exposure. Now this was, believe it or not, the Northern Lights photograph from St. Blazey in 2015. I always keep an eye on what's happening with the activity, the aurora activity, and then if I see there's a peak in activity, I'll rush out with the camera and get somewhere where I've got a better view towards the north. This isn't ideal because I've got a high horizon there because I'm in a valley, but I had to get away from the lights and the obstructions from my garden, so I just went a short way along this footpath. Just a 30-second exposure with a wide-angle lens. That's a Samyang 14mm lens, quite a wide angle, but also wide aperture, so it collects the light quickly. That display only lasted about 30 minutes, and it sort of gradually moved along the horizon there and just sort of faded out. That was shown on the sky at night, actually, shortly afterwards. Also, you can, a lot of you may have tried this, take photos of the moon through a telephoto lens. Best to spot meter on the actual moon, if you can set spot metering on the camera. Otherwise, you get it overexposed. But again, it's very easy to do. This was handheld. I think I just braced the camera against the door frame. Didn't even use a tripod in that case. It's best with a tripod, really. Okay. Next, we have photographing the sun and the moon through a telescope. Simple technique again, but of course you do need a telescope for this. These are short exposures. That's partly why it's so straightforward. You don't need very accurate tracking and whatnot. It's best to have a driven telescope, one that counteracts the turning of the Earth. But it's quite easy to set up. Okay, that's the moon photographed through a very small telescope, actually, just the Skywatcher 80mm refractor. And I've multiplied the magnification by 3 using this Barlow lens that you put in between the camera and the telescope. And as you can see, there's quite a lot of crater detail. There's Copernicus there, that's Tycho with the rays. That's all the ejecta that's flown out when the meteorites hit the moon. And this is the sun. I photographed this with that. I actually won this telescope, believe it or not. It's Coronado Solar Max, which shows it lets through just a tiny proportion of the sun's light in this one wavelength called hydrogen alpha, which is one of the wavelengths that the sun, any star, actually shines by. And it enables you to see details which you can only normally see during an eclipse, believe it or not. These are prominences, which are tongues of plasma coming off the edge of the sun. There's sunspots there, and you can see other prominences around the edge, but that's the best one. Very simple with a very simple setup, a 2 times Barlow lens, which because it's a tiny telescope, this one, that magnifies the view just by 2 times. You'll more or less fill the picture with the camera. Now we get on to images taken with a piggybacked camera. So these are ones where we're using tracked long exposures. It could be a star tracker, it could be where you fix the camera on top of the telescope on a bracket. So you use the telescope to guide, and you just let the camera do its thing and set it off doing a long exposure, say 4 minutes, 5 minutes, something like that. This was taken with a star tracker. This was only a very short exposure. It was only 25 seconds because I wanted to follow the stars, but I didn't want to blur the land too much. So you can see this small mountain peak there. This is taken just above the village of Kandersteg in Switzerland, because I've started taking the star tracker on holiday with me. So I can do a bit of, I can dabble in this while I'm away. And it's a beautiful site because it's just above the village. The sky was really dark. I don't think you'd get this in Cornwall so much. Certainly don't get it from my garden. That's the constellation of Cassiopeia, the W shape. There's the double cluster. It looks gorgeous through a telescope. You can see it there with this view with the wide-angle lens. That's the Andromeda Galaxy, which is 2.2 million light years away. That's the furthest object you can see with the naked eye. You can see it quite easily from Cornwall as well. And just think that the light from that galaxy has been traveling for 2.2 million years. And if I wasn't there to capture that image, the journey would have been wasted. That's the way I see it. Bear that in mind. This was a lens that I was given for Christmas in 1984, a Carl Zeiss Gina 135mm short telephoto. And I piggybacked the camera on top of the telescope, I didn't even need to guide because it's quite a short lens. I just had the telescope doing its normal tracking, it turns to counteract the Earth turning, and I was in watching Match of the Day or something. And I did notice at the time there was a bit of thin cloud going across, and I thought, oh, it's going to ruin the picture, this is going to be no good. But actually, I was pleased to find when I processed it that what it's done is it's put a bit of mist around the stars, and it's shown the colour a lot better. So these giant red giant stars show up a nice sort of orange colour, then you get the younger, bluer stars. These show up blue. And also you've got some nebulae. It's called the Monkey Head Nebula. If you see it close, you'll know why it's called the Monkey Head, but it's not so obvious there. This is the Jellyfish Nebula, which looks better close up, but showed up nicely in this wider view. This is a star cluster called M35. Again, it's better in a telescope, but you get a nice wide view with this sort of technique. Okay, next. Yeah, this is taken, I think it was actually just taken in the back garden, looking at the, this is the constellation of Cygnus. That's the North American Nebula, which is, there's a close-up of that one on the wall in the Enterprise Cloud Room, actually taken with a different camera. But this was taken with a wide-angle lens, piggybacked very simply on the top of the telescope for 14 2-minute exposures. I just let the telescope do the tracking, left the camera on a timer to do X number of pictures, and then used Deep Sky Stacker, which is another free program, to stack all the images to reduce the noise. And then I did various processing to improve the color balance, because it came out very red to start with. Sometimes they come out too blue, sometimes they're too red, so you've got to adjust that sort of thing. And also increase the contrast and reduce the noise, all sort of standard things that you need to do. Okay. Next we come on to planets photographed with a webcam. And I brought in my old webcam here. Oh, I showed you that just now, didn't I? Yeah, I did, yeah. Okay. Anyway, there it is again. I've just bought a new planetary imager actually to replace that one, which hopefully will do a better job, but I need to get a new laptop, I think, before I start messing around with it. Okay, there's Jupiter. Photographed with a webcam. It was something like a 1 minute exposure, well, 1 minute video clip actually, which was about 600 frames or 300 frames. And then I use Registax to select the best of the frames, and that stacks the images to reduce the noise, but also to reduce the atmospheric turbulence. Because if you took one single frame of a planet, chances are you'd have a lot of blur around the edges, and you wouldn't see much detail. But the Registax actually stacks all of those frames, or the best half of them, or whatever you choose, or you can hand pick the frames if you've got the time. And so that reduces the effect of the turbulence, and then you can apply convolution filters within the same software to bring out as much detail. I could probably take it a bit further, but you can see quite a lot of detail within the cloud belts, and you can see the great red spot there. It's not very red these days, but it's a huge storm about the size of the Earth that's been raging for hundreds of years. And Saturn, taken with the same 5-inch telescope, same Barlow lens, 5 times Barlow lens, and the same webcam. That's probably my best image of Saturn so far. You can see Cassini's division, which is this gap in the rings. My favourite planet, most people's favourite planet. Lastly, we have deep sky and comets through a telescope, and this is the technique which takes the most work and the most equipment. To be honest, I didn't really get into this properly until I bought a new telescope mount, which is very heavy and rock solid. I bought that in 2009. And so this is Comet Lovejoy. This is taken a 31 2-minute exposure taken with the camera through that same 5-inch refractor I mentioned earlier. And then I've stacked the images in Deep Sky Stacker with it lined up on the comet. So it's actually lined up on the center of the comet, not on the stars. And that's as the comet's moving against the star background over this time, so the stars will actually spread out. They trail like this. But the comet stays in the same spot, and you can see the tails there, dust tail. Well, actually, that's the plasma tail. Comet Lovejoy, discovered by Terry Lovejoy in Australia, and he's hot news. Yesterday, he's discovered another comet, and all his comets so far have been really spectacular, so fingers crossed. This might be the last frame, actually. It's, well, no, it's one more. This is a globular cluster in Sagittarius called M22. It's quite close to us, so you can actually see the individual star. Well, you can make out a lot of the individual stars. There's probably, I think there's something like 10 million stars in this cluster. It's a very, very tight cluster. It's a beautiful object through a telescope. This was taken through a 12-inch reflector, which is kind of, in some ways, my best telescope, in some ways my worst telescope. It weighs a ton, and it's very difficult to get really good images, but when you get something, it does really work really well, but a bit hit and miss. This is the last shot now. This is the Horsehead Nebula, which is a dark dust cloud silhouetted against an emission nebula. This is the star Alnitak, which is one of the brightest stars in Orion. That's the a nebula called NGC 2024, the Flame Nebula. And this picture is also on the wall in the Enterprise Cloud Room, actually. And if you look here, there's a line going across Alnitak, and that's a bit of a blooper. That was caused by my washing line being across the telescope when I took the picture. I didn't realise. So things can go awry. Things go awry a lot, actually. But anyway. So just the last frame, just to say, show some resources. These 3 software tools, I've mentioned these earlier, but they're all free to download if you search online. Star Trails is from a German website. Registax and Deep Sky Stacker are both from French programmers. As I say, free to download and experiment with. These forums have been really good. Cloudy Nights is an American forum, which I don't use it so much anymore, but I used to post quite a lot on there, and you get a lot of very useful feedback. And it's kind of pushed my photography a bit further, because I used to post up a picture and I was really proud of, and people would say, oh, it's okay, but what about this? What about that? You know, and I've followed their suggestions, and I've definitely made some improvements over the years. I've migrated in a way now to Stargazers Lounge, which is a British website, a British forum. Again, it's excellent for feedback and information, and you can search on there if you've got a query or whatever, or you can post the query yourself, and it's just really, really, really useful. So hope that's, I think that's it, yeah. Oops. Sorry, giving everyone thanks very much, cheers. Yep. I've given everyone a quick preview if you want.
Have anyone got any questions for Mike?
Oh, sorry.
Right, that aurora when you took of St Blamey, how much of that was visible to the naked eye?
The actual aurora itself was, well, it was visible. I was actually stood there for about half an hour before I saw anything, and I started taking some star trails just to kill some time. And then I started to see a faint glow on the horizon. And then I just kept watching, and I saw these streaks come up, but it wasn't bright enough, unfortunately, to see the colour. The colour is captured by the camera straight away, because it's there. It's just that your eyes are not, when it's that dim, your eyes are not sensitive enough to pick it up. When I've seen aurora, actually other times in Cornwall, I saw one in 2003 and another in 1999, which were bright enough to see colour covering the whole sky, pinks, blues and greens. And similarly, I once seen once in Iceland where there's been colour. But if it's quite faint, you don't see the colour, but the camera will. So if you think there might be an aurora, take a photo, and if you see the colour, you know there is one, even if you can't see it with the eye.
Is there a recommended app for giving you aurora alerts?
Yes, well, I use Space Weather, which is a NOAA website, and they're always coming up with predictions and whatnot, and also a lot of people post photos on there, so it's very useful. There's other ones as well. There's one based in Finland. Unfortunately, I've forgotten the name of it now, but I'll post something in the group later if I can find the link. That was quite useful because it gives almost a live view of what part of the planet is covered by the aurora. And I've actually seen that one and rushed out with the camera. In fact, that 2015 aurora, I did see it on the app and then rushed out. So and there it was. So can be quite useful. Okay, all right. So thanks so much.